Good afternoon, and welcome to Polymer and the Web Components Revolution. If this is not the talk you thought you were in, we've barred the doors. So first, just a little bit about me. My name is Matthew McNulty, and I lead the Polymer team here at Google. I started actually 2 years ago today. Came to Google to build Polymer. So my Twitter handle is on there. It's Matt S. McNulty. And yeah, so feel free to tweet me. Throughout the show, I don't have my phone on me. So just a little bit about what we're going to do today. So the first thing is going to be give an overview of Polymer. We'll also be talking about the ecosystem of which Polymer is a part, and discussing material design on the web. But to start, at the keynote, you might have seen a glimpse of an app the Polymer team's been working on over the last few weeks. And we codenamed it Topeka for entirely esoteric reasons. It actually has nothing to do with the city in Kansas. But in fact, it's a trivia application. So we spent a lot of time over the last year shipping web components natively, building elements, and evolving Polymer. But the true test of all of that is building an application. So Topeka is the app we built to test Polymer and material design. So it's a real app, and a handful of Polymer engineers built it over just the last 3 weeks. So just like the rest of Polymer, it's open source, and we've made it public today. So here's the URL and a QR code shortcut so you can follow along. This works best on Chrome Beta and Canary in 37, so that's pretty cool. Everyone's actually doing that. It works great on desktops. It works on other platforms as well, but it's best on Beta and Canary locally. So just a little note, since this was shown and tweeted about during the keynote, I think we're up to about 5,000 or 6,000 users so far. So our big plan to show the leaderboard evolving over time during this talk probably is going for naught. But welcome to join in. All right. So I'm going to demo Topeka now. So we take it over to the demo machine. Wrong demo machine. There we go. All right, so this is Topeka. I'm running it locally because of internet issues at conferences. And at the very beginning, we've got a sign-in page, and you can see from the beginning that we've got these cool ink effects on the inputs. I put my stuff in here, and you can pick an avatar. So I usually pick the dog because I'm a dog person. And from the very beginning, you see really cool transitions, and this is all built in and part of Polymer. We can show that one again. So it's really, really cool. So let's pick out a category. Let's do food and drink. So it's important to note at the start that we are not trivia experts. So some of the answers were actually wrong as recently as a week ago. And some of these are incredibly hard. So there's one coming up that I don't think I've ever actually gotten right, and I haven't looked up. So all right, audience participation time. Name the Italian semi-soft rich cheese with blue veins through it. That's a smart audience. All right, coffee beans contain more caffeine than tea leaves. This is a good audience. All right, now we get to the question that I have gotten wrong every single time. Okay, we got honey. Hey. Somehow I was missing water and all that. That makes no sense at all. All right, so there you go. There's categories. And we can check out the leaderboard, see how everyone's doing. Actually, there's people who've done remarkably well this morning. I think when we did this test in the Chrome team, I think it got someone was in the 400s, but that was about it. So someone's done pretty well. We even have a standalone one that shows it a little more completely. Once it loads up, welcome to Conference Internet. Aw, come on. Always have a backup plan. All right, so as you can see now, no one has any scores, but as it goes and as we batch the updates and they animate around, it's really pretty cool. And you can see a little bit of the material design aspects here as the pieces of paper come off the screen and then mold back in as they get to their new spot. So we'll check and see if the leaderboard works later on. But another thing to note about this is that it's responsive. So if we come back to the app, and I pop out of full screen mode, so the same app actually adapts across phones and tablets with the same animations. So this is cool, but we need to actually prove it. So can we go over to the Wolf Vision? There we are. So you can see here, this is exactly the same app. This is running in Chrome beta on Nexus 5. And we get to answer. Now we know all the answers, so it's pretty cool. So you can see it's actually the same fast, smooth animation and the same responsive design across mobile and desktop. So let's go back to the presentation. All right, so that's Topeka. We'll check back later, see if that leaderboard works and see how everyone's doing, but we probably won't. So for those of you who haven't lost to playing trivia, and this is kind of the big problem with this application, is even showing it to executives, they get immersed in the actual trivia and lose everything else that I'm saying. This is the kind of immersive experience typically associated with native applications on mobile devices. So you might be thinking, but this is the web, and the web isn't supposed to be able to do this. The web is for content, the web is for documents, the web's for the boring stuff that you stick in the middle of a hybrid app. So how did we actually do this? We did it with Polymer, and I'm here today to show you how. So to start, what in the world is Polymer? So Polymer is a library that makes building applications easier, which sounds pretty generic. So let's dive into a little bit more detail. So if you take away anything from this talk, make it this. Polymer is a different kind of thing. So all comparisons to other things and things that have come before are imperfect because there hasn't been anything like this before. So first off, the process of building Polymer was very different. And the reason is pretty simple. The Polymer team is part of the Chrome team. So when we started this project 2 years ago today, we were given a mandate, and that mandate was use the platform. So previously, best practices included building frameworks that are above the web platform, or even bring their own platform they stick on top. So some just use the web platform like a rendering layer, like our last framework. And as a result, Polymer doesn't fight the platform because we're on the web platform team at Chrome. It's us. So there's a room full of people in multiple offices who surround us, who are responsible for making the web platform great. And they keep us honest and keep us from using our bag of tricks to get around problems. And we keep them honest by stopping when we find something that doesn't work and filing bugs or pointing it out. And a lot of times, the person responsible is a few feet away. I can think of a couple people in particular. So if we run across some source of jank or something that doesn't seem to work right, we yell across the room for someone to take a look at it. And bugs are filed, and the next version of Chrome gets better, and Polymer gets better, and more importantly, the whole web platform gets better. So Polymer is the first library of its kind. It's not just because we were part of the Chrome team, because it's made from a different foundation. It's made from different parts. And that foundation is web components. So who here has heard of web components? All right, that's pretty good. If you haven't, you definitely want to stay right here for the next talk, as Eric Beidelman's going to talk all about that in Polymer in a lot of depth. So web components are a set of new standards. And my slide formatting got a little screwed up here. So you'll have to bear with me there. So there's standards on the bottom. So Polymer isn't just a Chrome thing, it's a web platform thing. And Polymer is just leading the way so far. Oh, this slide formatting is killing me. So if you don't know about web components, you might know this already, but if you don't, here it is. So web components utterly change the web platform. So we use lots of grandiose terms when we talk about this. Revolution, changes everything you know. This isn't hyperbole. This actually changes everything. And web components introduce a new world where components from different vendors can live together on the same page. So apps can be crafted out of parts that are found on a massive shelf. So the web becomes interoperable with custom elements, which is what that's supposed to say. So web components make composing applications out of these components possible. So Shadow DOM is about composability, and only that. So a lot of people think it's about security, but that's not really true. So it gives you just enough of a container, just enough, that the web becomes composable with Shadow DOM. And finally, web components introduces resource loading and external dependencies to HTML. So think about it. How long have you been able to have external CSS and JS files, but never HTML? So it's a really simple mechanism, but it's really useful. So the web is now consumable in smaller chunks with HTML imports. And all of this is shipping natively starting in Chrome 36, which is the beta channel right now, and it'll be stable in just a few weeks. So does this work only on Chrome? No. So thanks to polyfills, this works across more browsers than you'd think. It's actually the last two versions of just about everything. So there's a misconception out there that Polymer is the polyfill layer for the web components because we happen to write them, and that's what we talked about last year. But the polyfills aren't Polymer, but let Polymer elements and applications run on other recent browsers. All right, so Polymer is based on web components, and web components are awesome. But what does Polymer actually do? What's its purpose in life? So Polymer provides a sugaring layer on top of these new web standards. So web components, as well as others like the template tag. So it tries to be a thin layer on top. But since these new standards are so awesome, why do they need sugaring? And it's because primitives are primitive. So this sounds funny, but it's true. Think about Legos, right? The best Legos aren't the weird castle wall chunks or specialty bricks that all of my older siblings claimed were complete sacrilege. They're the basic ones, right? Because they are the most expressive. So new features should be as primitive as possible. So developers can do things within the browser vendors would never dream of. And Polymer reduces boilerplate. So for various very legitimate reasons, primitive APIs can require a lot of boilerplate code or quirks that can get really, really repetitive. Our goal with Polymer is to reduce the code that developers write to just what is unique to their application. So DRY is our motto, don't repeat yourself. So Polymer also introduces a declarative syntax. So Web Component Spec has a declarative syntax in there, but it's not been implemented yet. So we built our own on top of the imperative. So this makes it really simple to describe your UI and markup. So Polymer makes all these new bits work together great. So a lot of times over the last year, there are people who set off to kind of do this on their own and do it without Polymer because they decided, oh, Polymer would be some big thing that they have to figure out. So they try and get it all working on their own. And they do, but it's a lot harder that way. So Polymer does all the hard work to make this all a cohesive system. And Polymer can do all this because Polymer has an opinion. So we think we have a great way to build applications and use all of these new features together to create awesome experiences for users. So there isn't a place for opinion in standards. You need another layer. So let's take a look more closely about how you can use Polymer. So when we talk about using Polymer, we divide the world into two use cases, using elements and creating elements. So the long tail of users out there just want to add something to their website, right? Like the DHTML calendar that people have been using forever. It was on like every website in the 2000s. Or a download button or this thing or that thing. Using elements is something that web components and some best practices make possible right now. But the people in this room or listening to this talk are likely also interested in creating their own elements and using all of the Polymer features to do so. So let's cover using elements first because it's really easy. So the first step is find the element you want. You can do this a lot of ways. There's GitHub. We like Bower on the team. Or catalogs. We're building one. There's others out there already, actually. Or just a zip file hosted somewhere. Step 2 is to import it. This is where HTML imports comes in. This link tag with rel equals import is an HTML import. So you'll notice what it's importing is HTML. In this case, it's the HTML file that has the definition of my button. And the last step, there's only 3 steps, is use it. So once the element's imported, you can use it on a page just like any other element. And that's it. That's all there is to using custom elements with web components. And Polymer elements, just like custom elements in general, are just HTML elements. So I put just in quotes here because now that HTML is extensible like this, HTML elements become really powerful. And with this new power, it becomes possible again to use DOM as the object model as it was originally intended to be. So we like to call Polymer a library, not a framework. I mess this up a lot. I might even today. Because with Polymer, the framework is DOM itself. It's a return to the early days of HTML, when your UI was expressed in HTML and manipulated using DOM APIs. So let's take a look at how we create elements with Polymer. So we identified the most common things developers will need to do to create web components and focused on making that dead simple. So this is the sugar that we're layering on top of web components. So we'll use this simple counter element as an example. It just has a label, a value, and a button to increment. Oops. Did I get that video working? Huh, that's interesting. It doesn't actually animate on my screen, only yours. All right. So using standard APIs, creating and registering our counter might look something like this. And that's a lot of typing. It works, but it's not really sweet. With Polymer, we can accomplish the most common tasks declaratively and with much less code. So the boilerplate's gone, and you're left with code that's unique to your application, which I mentioned is our goal. So let's take a quick look at some of the features Polymer adds on top of web components in a little more detail using this exact example. So first, you can create and register a custom element declaratively without any JavaScript. So you just wrap your definition in a Polymer element tag and give it a name. So now my counter is a valid HTML tag you can use in your app. It just doesn't do anything yet. Next, we can include an HTML template in the element that captures this element's view. So it can contain any arbitrary HTML, including other custom elements. Here, we'll put a couple of divs and a button in to make our counter. This is pretty just standard HTML. So next, we add styles to our template. So since the template will be rendered into the shadow DOM hidden from other elements, these styles will only modify our component and won't leak out and modify other parts of the application. So this is how shadow DOM enables composability. Next, we can define published properties on the element's prototype. So published properties in Polymer can be initialized via attributes on the tag in markup, and observed simply by adding a changed handler function. And Polymer comes with two-way data binding, which binds the values of our element to the view using mustache syntax. So Polymer supports complex expressions, but in this case, we're just binding the contents of the span to the value of the counter property on the prototype. We also provide event binding, which reduces the boilerplate needed to set up event handlers. So in this case, when the button is tapped, it calls this method on the prototype increment and increments the counter. And all this together makes defining and composing your custom elements a lot easier, maybe even sweet. So with all of this, what can you make with Polymer? I get asked this a lot. And the answer is absolutely everything, or everything. So whole cities even, if you believe this photo. So the truth is Polymer is a really low-level UI library, and it can express a lot of different things. Like quiz apps. So at least we know it's good for quiz apps. We've made very, very good quiz apps. But you can also use Polymer to make apps out of elements and elements out of other elements. With Polymer, everything is elements all the way down. Those are the core building blocks. You can also use Polymer to build sets of elements, predefined building blocks that others can use to build elements or applications. Some of those elements are visual, like buttons and tabs and sliders and inputs, and all the standard things you'd need to build applications. But other elements are utility elements that don't have a UI. So this can sometimes strike people as strange, but if you think about it, HTML has script tags, a head tag, title tag, style tag. These all don't necessarily have any UI at all, but they're still HTML elements. Polymer didn't invent this concept. So the first set of elements we've been creating out in the open over the last few months is Polymer core elements. So these are basic elements that are generally useful and don't have a lot of style. There were some blogs that thought this was the future of Google style, but hey, they don't actually, intentionally don't have a lot. So some of them are utility elements that you would find in frameworks in the past. But with Polymer, those don't have to be baked in at that level and can be used a la carte. So there's a few dozen of these core elements, and these are just a few of them. So it's everything from icons and tooltips and buttons, and some of those utility elements, like core Ajax. So core Ajax makes Ajax calls dead simple. Core local storage makes persistence as easy as binding any object to it with data binding. You've got a piece of data, you bind it to local storage, and it persists, and that's it. That's all you have to do. So all the core elements start with a core dash namespace, and as we move forward, you're going to see more of the gaps in Polymer filled using elements like these. So we get asked about routing or internationalization. We have some of those experiments already out there. But you'll see these show up in the future likely as elements not baked into Polymer itself. So over the last 6 months, we've been working on another set of elements, ones that push the boundaries of what's possible on the web. Today, we're unveiling that set of elements as part of the material design effort, and we call them paper elements. So material design unifies the rich user experience across all devices and allows developers to create rich, immersive experiences. So here's a quick look at what we've made public today. So we built a sampler app that showcases the various paper elements for developers, and that's also available today. It's linked off our homepage. And this is just a brief taste of it, so let's take a look. So we've got checkboxes and radio buttons, toggle buttons, and all of this reacts to both mouse and touch, so it works across mobile and desktop alike. We have really cool input tags. They have that ink effect I showed you earlier. We've got validation. That's pretty cool. We even have these neat floating label ones, which we like to use a lot because it's a really neat effect. So you see us use those all over the place. So all of these are available today. They're all in the sampler, and they're all a work in progress, and they're going to continue to evolve. So we've also introduced a bunch of primitives to create really fancy animations. So from cross-fading scrolling headers that return on scroll up, like you see right now, to systems that allow the UI to animate across states while the focused object, or hero, morphs across. So this is one of the principles of material design, is that the object that's in focus of the user should stay as you morph across these different surfaces. So when you put it all together, you get Topeka. And this is a little video that they showed this morning in the keynote that kind of shows you how it all comes together. And this is all public today on the Polymer website. So the title of the talk mentioned a revolution, and this is all certainly revolutionary for web development. But Polymer is only a smaller part of a bigger story. And this is the ecosystem that Web Components is creating. So Polymer is at the forefront of this revolution. We're the pioneer, to mix my metaphors. But we're not alone in this endeavor. Others have already joined us. So our friends at Mozilla built a similar library called Xtags, and have begun a set of elements called Brick. So Xtags and Brick are roughly analogous to Polymer and paper elements. So both Polymer and Xtags are built on top of the same polyfills, the ones we announced last year. So because of Web Components, these libraries can complement each other. We're not actually competing and can work together, because developers can mix and match. So Polymer is bootstrapping this entire ecosystem. And there's already registries of elements, like at customelements.io. Component Kitchen's a cool effort by a friend of ours to build a catalog for these components. And webcomponents.org exists for web developers to exchange ideas on these core concepts. And all of these are in addition to the Polymer website and mailing list that we're creating. So as you can imagine, most of this work started from scratch, and it's a really big job. So we're moving on a lot of these fronts all at once. This new ecosystem and method for building applications out of all these individual components requires a lot of new tools. Some of those tools we're building. So last year I showed off a demo of the designer tool for components, and I used it extensively during my talk. This year we've made it look more real, or made it more real. So you can use it to prototype and build elements and save and share them. So we call it Polymer Designer, and we recently put it up on our website as well. And an updated version launched today, and we'll take a look at it in a minute. And one thing we hear a lot is about how building apps out of discrete components breaks network performance optimizations by causing a lot of requests. So we built a tool called Vulcanizer that for deployment can bundle together all of your imports and components into a single CSS, JS, and HTML file. So it even has flags for deploying to CSP environments. And testing is also an area we're working hard on that people have asked us about. So right now we use Karma, Chai, and Mocha, and we built a harness for Mocha that enables HTML-based tests, rather than just JavaScript, as unit tests are done today. And we've even built an element called Core Component Page that can look at a component and create a nice documentation page for it. All you need to do is include one in the index.html of your repo, and the rest just works. So we've seen how Polymer can be used to create immersive experiences across devices, across phones, tablets, and desktops. Anywhere the web goes, and that means TVs with Chromecast as well. So Polymer and Web Components goes everywhere the web goes, and the web has massive reach. So in fact, my friend Alex has been working for the last few weeks on a component that lets me push notifications to a watch from a web app, and I happen to have a watch right here. With Web Components, I can go find the element I need, import it, and use it. So let's see how this all works together. Over the demo machine. Which one's asleep? See if the leaderboard's working while that's loading up. Wah, wah. All right. So here we have a catalog. This is the catalog we've been working on. It's not public yet because it's still pretty much a work in progress. And I happen to know that the element I need is called notification elements. So I can come to our catalog and download it. It gives me options to download and zip, the commands for Bower, or GitHub. GitHub's a little dangerous because it doesn't pull down all the dependencies for you like the other ones. So let's go with a zip. So now imagine, through the magic of I/O, that magically got over into my designer here. So we'll act like that just kind of happened. So this is the designer tool, which I talked about before. So we've got a large canvas area. Looks kind of like we had last year, but it's a little updated. And then on the right-hand side, we've got a property inspector that allows you to inspect the properties of something you've dragged out, and a palette of components to drag out, and a tree that lets you select things that are in the canvas that might not otherwise be selectable. So we're going to add notifications to Topeka. So first, I'm going to drag out the app. And like everything in Polymer, everything is an element, and everything works in the designer tool. So I can actually drag out the whole application. Maximize it. And I need to connect it to a data source. So I'll do that. And then I have to connect the two together. So let's give it a user. So I already logged in on this machine when I was doing the demo earlier, so it already has the user local. And let's give it categories. So this is all just using the data binding features I was talking about before. Boom, and we have our whole app. So this actually works right here in the middle of the designer. It's pretty neat. But we want to add notifications. So we come back here to components, grab our notification element. So this is one of those utility elements, right? It doesn't have a UI. And it has a hard-coded message to begin with that says, hi there. So let's fix that. And instead do Topeka app.user.score. So now when the notification is triggered, it'll push the score to the device. But there's still a little bit I have to do to wire it up. So let's flip over to code view. So this is the code that we're creating. And notice that so far I've done no JavaScript whatsoever. This is all just HTML and data binding. So I'm going to add an event handler to the quiz. Which I happen to know is called onQuizDone. And I'm going to use the event binding so that it'll call this method when this event is triggered. And now I actually have to define the method. All right, so what I did there is when the quiz event, onQuizDone event happens, it calls QuizDone. QuizDone grabs the notification alert element that's sitting here on the page right here, triggers its notify method, and gives it a message of Topeka app user.score. And now if the demo gods are shining on me a little better than they were before, I should be able to go. I can go over to the Wolf Vision in a second. Have me not show off my password to all of I/O. Reload it. Oh, sorry, wrong run. That was my fault. I'm just going to sign in here really quickly because that's the boring part. Choose an avatar. All right. So we have our app here. So people tell me that you don't want to demo anything with Wi-Fi or internet, and apparently Bluetooth is even worse in an environment like this. So who knows if this is actually going to work? But let's go back to our favorite category and answer the questions we know about already. Gorgonzola. Hey, there we go. And it pushed 8 to the device. I went to sleep at exactly the wrong time. Can we get back to the presentation? All right, so that's just a little taste of the ecosystem that's being powered by Polymer and web components. So what have we learned about today? So we've learned that web components are awesome. And if you want to know how awesome, Eric's going to talk about that in a little bit. We've learned about Polymer itself and how to build elements and use elements. We've learned that we've built a lot of elements already, and they're come in 2 different sets so far of core and paper elements, and there's a lot of other ones out there. And that Polymer is just a small part of a really big ecosystem that's starting, that's all powered by web components. So this ecosystem is just getting started, and there's a lot you can do to join the revolution. So you can build an element. wrap an API. So this has gotten really popular at Google. There's a lot of people building like cloud APIs or even browser APIs that have figured out that if you wrap their API in a custom element, it makes it really consumable and easy for developers to use. And they can also stick it in a designer tool, and it's been really fun. You can build an app. So we built one, now it's your turn. We'd prefer it not be a quiz app because we've already done that. You can stay put for Eric's talk in just a little bit right here in this same room. And come check out Rob at 4. So the ecosystem's just getting started, but we're also just getting started. So public today is the Polymer developer preview. The paper elements also went public today. New version of the designer, a brand new tutorial, a whole new onboarding experience, documentation for everything. It's all still a work in progress, but it's all public and available today at polymerproject.org. So that's Polymer. So we'll do some Q&A in just a minute, but I just wanted to give you a quick reminder. So if you stay here in about 29 minutes, Eric Beitelman will have Polymer and Web Components change everything you know about web development, which is officially the longest title in I/O history. And then at 4 o'clock in room 4, which is pretty easy to remember, it's Unlock the Next Era of UI Development with Polymer. And Rob Dotson's doing that talk, and he's going to do a really deep dive on the material design and paper elements aspect of Polymer. It's going to be really cool. So there's the thank you slide. There's the feedback URL. Appreciate any feedback you have there. And let's go to questions.
My questions are about material design, which makes me wonder if I'm in the wrong talk. But I noticed that when you shrank the browser window to begin with, that the elements didn't resize with it. Is there a vision to do that with Polymer paper to where when you responsively resize a window, the elements will still track in place rather than just popping between media queries?
I think it depends on which screen you are viewing. Right? So I think some screen, it depends on how it's set up. Right now we've got it set up to have kind of a card in the middle, and it changes as you go. Depending on which scaffold you use and how you build it, some of them are more responsive than that. So it really depends. Most of the widgets are their whatever width of their container. So if the container changes size, it'll just change size.
Okay. And the follow-up to that, I know that Polymer is very cool, but it's also very much a prototype right now. And for people who are building projects that need to get out the door today or using frameworks like Angular or something else, will there be a way to incorporate Polymer paper and some of the cool UX things you guys are doing with other frameworks, or do you sort of have to throw it away and start from scratch with Polymer?
So that's one of the really cool things about custom elements is that they're just HTML elements, right? So anything that knows how to deal with HTML can also use Polymer elements. So one of the things we like to talk about with this is that there's kind of this barrier, right? There's the world outside of an element, and there's the world inside of an element. So from the outside, Polymer elements look just like every other HTML element, so they have properties and methods and attributes. So they can be consumed by anything that uses HTML or pushes out. It's inside the element that you have all the goodies that Polymer provides. And that's where, if you were actually inside building a Polymer element and you started to use other frameworks, you could get in trouble, mostly because they don't know how to deal with shadow DOM and things like that. But from just using elements, including the material design elements, you can just do that today.
Okay, thanks.
Next. We go in the back.
Yeah, so 2 questions about the ecosystem. One, is there any component directory that's trying to include both Polymer components as well as Xtags components? And then can you speak at all about other browser support, Safari in particular?
Sure. So to the first question, some of the ones I showed you there, like customelements.io is a registry of all elements, regardless of whether they're Polymer or not. The catalog that we're building is intended to be just web components and not Polymer specific as well. I think you saw that in the title. So I think the idea is that it doesn't really matter how you built these. Again, kind of going back to the answer of the last question, they can still be consumed by everyone. And then what was the second question? Sorry.
Safari support or any other
Safari.
browsers that have committed?
Sure. So you're talking about native support specifically, right? Yeah, so Mozilla has progressed quite a bit. They've shipped Shadow DOM. They have not shipped custom elements yet. They've shipped custom elements, not Shadow DOM, sorry. I had to look for a little support there. But they're working on it. They're working on it very actively, and we're talking to them a lot. Safari, we don't really know. They're not very public with their plans about these kinds of things. They have expressed interest in the topic, especially lately, and that's a really good sign, but we don't really know. The polyfill, so people who are using this, like Salesforce.com, have been using the polyfill, especially for mobile Safari, and have found the performance to be pretty acceptable. It depends on what you're going for. So if the people ask about the performance of the polyfills a lot, and it's not really about performance, it's more about API compatibility. But most people have found it's relatively respectable.
Thank you.
Who else? Huh, answered his question too. Anyone else? The question was, what about IE? You want to give me the official one on that? So IE has recently started being a little bit more open with everyone about what their plans are, and they seem to be interested in web components. We don't really know. They don't tell everyone their plans, but they seem to be they're involved. You actually see them pop up on our mailing list occasionally, and they've done some experiments internally on Win.js and Polymer together that we've helped contribute to. So they seem very interested in Polymer and web components in general, but we're going to have to wait and see. In the back?
Yeah, I was wondering, so what we've seen with material design demos today, the performance in the browser looks incredible. How much of that is unique to work Polymer has done? How much of that is just continued work by the Chrome team to improve performance?
Sure. So they're actually kind of intermixed, if you think about it. So because we're part of the Chrome team, we're a lot of the people that are causing the bugs to be filed, that are getting fixed, that are causing things to get faster. And at the same time, we're also codifying a lot of the best practices of the Chrome team into the elements themselves, so that when people use them to create things, they're automatically on that kind of well-lit path. So it's a combination of both. Anything else? We got one more.
Just kind of a follow-up on the performance. Could you talk about the long-term performance of using DOM elements and DOM manipulation versus frameworks like React that try to minimize DOM?
Sure. So I mean, it's definitely a different world, right? So to start off with, today with the polyfills, Polymer is basically as good as any other existing JavaScript framework out there. We don't do anything worse. So the idea is that it's even better on Chrome because that has native support. So that's kind of the first thing I wanted to say. The other thing is when the team that works on Polymer worked on a framework called Enyo at WebOS a few years ago that had philosophically React and Polymer and Enyo are all kind of similar with a component mindset. But they had an idea of you never touch the DOM, right? The DOM is slow, and that's how you never want to touch the DOM. We'd actually just squirt in inner HTML, giant HTML strings that was the fastest path. And then when we came to Chrome, the guys at Chrome were like, no, that's crazy. We're like, no, this is the thing. And it turns out that that's actually been changing a lot over time. So once we had actually made it to Chrome, the DOM APIs were incredibly fast. So it turned out not to be the penalty we thought it was. So I think that it's an area of improvement potentially for Chrome as well, and I know they've identified a lot of things there. I think it's all public on the Blink mailing list as to how to improve DOM performance. But what's great about it is by relying on that core platform, there's one point of failure, right? There's one point that you can use to improve performance across everyone, and that's the Blink runtime. If you have your own whole framework on top or that has a server component, it's a lot of different things that have to come together and get faster all at once to get there. Anything else? All right. Thanks, everyone.